Welcome to today's lesson. You will need your notebook for notes and a pen or a pencil. Today we're going to talk about transformations in the coordinate plane, i.e. today we're going to be talking about reflections and translations. A reflection is just like a mirror image. You have a line and you reflect something about that line. All reflections have to have a line of reflection. Most of them will be the x or the y axis. So let's take a look at an example. I want to graph these 3 points and make a triangle. So R1 would be 1, 2, so I go over 1 and up 2. S is 3, 4, so I go right 3 and up 4. And then T is 5, 1, so I go over 5 and up 1. Make my points and I have my triangle. Now I'm going to reflect this across the y-axis, which means this is the y-axis. So that means that I count how many places is it from here to here. 1, so then my R has to just be one place there. And we call it what's called R prime, so we know which one our new point is. So my S is 1, 2, 3, so I go 1, 2, 3, and there's my S. My T is 1, 2, 3, 4, 5, so I go over 1, 2, 3, 4, 5, and I connect my points. And so there's my reflection. I note that it's reflection of the letter prime. You do not have to copy this down. So what we really do is have a rule. This is called a motion rule, and you should write this down as reflection motion rule. A reflection in the y-axis, the rule is xy becomes negative xy. So your y stays the same, but your x becomes its opposite. If I'm reflecting in the x-axis, it's the opposite of what that is. xy becomes x and negative y. This is really important, and you need to understand these rules. So you really need to make sure you write those down. Let's do an example of what I'm talking about. So if I reflected 3, 2 on the y-axis, what would the new point be? Well, I'm doing on the y-axis, so that means I take the opposite of the x, which would make it negative 3, and the y stays the same. So my new point would be negative 3, 2. What about reflecting 1, 3 over the x-axis? 1, negative 3. So the next thing we're going to talk about are translations. And translations are slides in a coordinate plane. So you need to write down everything on this screen. If you're going on the x part of your point, remember coordinate points are always xy. The x always goes left or right, and the y goes up or down. The left means you're subtracting, and the right means you're adding, and that's going to make sense in just a second. Up means you're adding, and down means you're subtracting. So please hit pause and make sure you write all of these down. So let's look at what a translation looks like. You can have a 1-point translation where it just moves one time. One of the coordinates stays the same and the other one doesn't. So this is just a flat out slide. I want to see how the red becomes the green. So pick a point on the red. I'm going to pick this point here. And you count to see how many it goes over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going right 10 places. So the translation is 10 right. So let's take a look at this one. This one's moving over and down. Same rule. I'm going to pick a point and see how it goes from here to here. So it goes 1, 2, 3, 4, 5, 6, 7, 8 right. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. So now let me show you what I mean when I'm talking about rules. If I wanted to plot the points 6, 4, 6, 2, and 8, 2, and translate them left 7 and down 3, my motion rule would be I go minus 7 on the x and minus 3 on the y, because left is minus and down is minus. So my rule becomes x minus 7, y minus 3. So let me show you, what would my new a become? Well, what's 6 minus 7? Negative 1. What's 4 minus 3? 1. And we call it a prime. What would my b become? Well, 6 minus 7 is negative 1. 2 minus 3 is negative 1. And what would my c become? 8 minus 7 is 1. 2 minus 3 is negative 1. So you actually don't have to graph anything as long as you know your rules, which will save you in the long run.